So for the MasakhaNEWS, this is a recent paper by MasakhaNEWS, and it was submitted to Africa NLP at ICARE 2023. And this paper was also created, and also it was created using this participatory research approach. What is the task of news topic classification? It's a sequence classification task. It's a very simple task, and you can evaluate this quickly by accuracy or F1 score. If someone tells you 5 things to know about Nigeria, Nigerian new Naira notes, what will be the category for this? If you know it, you can type on the chat. What will be the category for this? Okay. And I think this one would be business news. What of this other sentence, Joy Boyega don't win GQ Icon Award for the second time? I think the second one will be entertainment. What of the third one? What will be the category? Health. Okay, great. And the last one. Okay, excellent. Sports. So I know some people are following. So we have sport news, and we can do this categorization just looking at the headline. But the question is that, can we build a model using a combination of this self-supervised pre-training and with few examples, can we build a powerful model to do news topic classification for African languages? And before we address that, I want to tell you that in the last 3 years or 4 years, when we started working on this, we do not have a lot of data sets that we can even use to develop NLP models for African languages. If you look back towards 2019, you find out that we only have few data sets, like WikiNN, CMU Wilderness. And this data set, for example, NER was automatically annotated, created, and CMU Wilderness was also not created from the scratch. The data set that were available were either in people's computers or you have to pay for them. So, but this is what we have done at MasakhaNEWS. We have created several data sets. So, and there are even more, but I just listed some, like we have created for name basis recognition, for part of speech, for news topic classification, for machine translation, for sentiment analysis, for text to speech, and so on. Then the question is that what happened between 2019 and 2023? I can identify like 3 interesting initiatives that really encourage the creation of data set. The first one is Zindi ML competition. Some of you might be aware of this, and where they want to organize machine learning competition across Africa. And one of the ways to encourage people to participate is also to release their data set so that they can create this ML competition. And this also encourages some people to release some of the data sets, for example, parallel translation data set they have on their computer. We have the Africa NLP workshop that started in 2020, organized by MasakhaNEWS. And most of the artifacts of the workshop is that people create a new data set that can be used for NLP to create NLP models for African languages, and so on. And we also have some funding initiative like AI for D, supported by GIZ in Germany, IGS in Canada, Lacuna Fund supported by different organizations like Rockefeller Foundation, Google, and so on. So this has really helped to create more data sets that we can now use for to develop NLP models for African languages. So if you're coming into NLP in 2023, you are so blessed because you have so many data sets. So you have like at least six data sets. If you search very well on the internet, you might even have up to 10 tasks that you can now benchmark on and start your research without having to create a new data set. And one of the organizations driving this is MasakhaNEWS, a grassroots NLP community for Africans and by Africans. And we pioneer like this participatory research. We have over 1,900 members on Slack, and it's a very active community. And the very first data set we created was name-based recognition data set. And after that, we have created other data sets that we now use for NLP research. So, but today we'll focus on MasakhaNEWS. First, let's talk about the languages that are covered in our data set, the data source and the annotation. Then we go over to the baseline models and results. And then we finish off with zero-shot and few-shot approaches, where we can use the more recent approaches to do news topic classification. Okay, so why do we need to create MasakhaNEWS? Yes, we do have previous data sets. For example, in 2020, recently, we created Hausa VOA and Yoruba BBC news topic classification. And this is only based on news headline. But even for Hausa and Yoruba, they have different label configuration. Yoruba has like, I think 7 categories, Hausa has like 5. So we also have another data set called Kin News and Kiru News. This is for Kirundi and Kinyarwanda languages. Again, these two data sets created by the same author, they have different label configuration. Another one is Amharic news topic classification, which was semi-automatically annotated. First, they look at the categories of news on, I think, Voice of America, and they group the data set like that. And then they now did some few verifications. So it's semi-automatically annotated. And we have another data set which we published recently called ANTC. It's also based on this idea that we crawl data based on the predefined categories on their website. But again, they have different label configuration. And sometimes some of these predefined categories also are not that interesting. So for example, you can have a category on vehicles and then what? It's not very interesting for news topic classification. And that's why we created this. Our contribution is to create MasakhaNEWS, which is a news topic classification data set for 16 languages widely spoken in Africa, including French and English. Also, we provide evaluation of baseline models by training classical ML models. For example, anything you can use on scikit-learn, like naive Bayes, and then we also fine-tune language models. And we also provide several alternatives to full fine-tuning methods that are better suited for zero-shot and few-shot adaptation. For example, you can prompt ChatGPT, or you can also do cross-lingual parameter efficient fine-tuning. There are other methods like pattern exploiting training and prompt-free sentence transformer fine-tuning. And this is interesting, especially based on the hackathon with Cohere, because you could leverage few examples to classify new instances. Okay, the MasakhaNEWS project actually comprises of different stakeholders, including native speakers, linguists and language experts, and NLP and machine learning experts from around the world. If I'm correct with my statistics, I think we have around 8 from North America, like 38, from Africa, 15 from Europe, and I think 1 from Asia. So it's a large collaboration of 62 authors. And it's a very interesting project which we started around late last year. And if you look at these data sets, you will find out that we have, it's very diverse in terms of the geographical diversity of the languages. We have some in Nigeria, outside Niger, Yoruba, and Igbo. We have Lingala in Central Africa. We have Tigrinya, Amharic, Oromo, and Somali in Ethiopia and Somalia. We have Luganda in Uganda. We have Rundi in, We have Rundi, I think, in Burundi. We have Kiswahili in the entire East Africa, Shishona and Isikalsa in southern part of Africa. And we cover different language families from Afro-Asiatic. I think we have like 5 languages. I think this is the first time in MasakhaNEWS that we cover a lot of Afro-Asiatic families, languages. We also have several Niger-Congo languages, and it's a very including English and French. So there's a lot of linguistic diversity and geographical diversity in this data set. And where did we get our data from? Our data mostly comes from BBC articles in most of these languages, followed by Voice of America in 2 languages, Lingala and Shishona. And where these two publishers are not available, we use some indigenous newspapers like ISO, the word ISO Levswell. I don't know how to pronounce it very well, sorry. From South Africa. We also use another one from Luganda and another one for Shishona, which is just the spot news. And if you look at the sample of the number of articles versus languages, most of the languages have more than 5,000 articles that you can crawl. But some languages do not have a lot of data on the web. For example, I think in Nigeria, we have less articles, for example, for Igbo compared to the rest of the Nigerian languages. But for across Africa, we even have less articles for Lingala and Luganda in general. But in general, we are able to collect like few thousands, like over 2005 articles for each of these languages. Next, how did we do the data annotation? This is quite interesting because we have to now study, we were inspired by the BBC English categorization. So this is an example of the BBC article. If you look at the BBC article, you can see some interesting categorization. For example, if you click on culture, it's actually talking about entertainment and arts, which we can categorize as entertainment news. We have sports category on the top. We have business, politics, tech, and health news. So these are interesting categories. So we decided to adopt these categories used by BBC. And each of these categories in the BBC has over, I think has over 500 articles. So we crawl them, and our target will be to have a minimum of 3,000 articles per language. But while we're doing some initial annotation, we decided to add religion because we found out that a lot of articles were categorized as religion. So we decided to add this because in Africa, it's also very prevalent. So MasakhaNEWS, we adopt what is called active learning for data annotation. The idea is that we first recruited volunteers from Masakhani that annotated close to 3,000 sentences. And our intention is to have a minimum of 2 annotators per language, but we find it difficult for Luganda and Kirundi because the second annotators dropped or were not able to finish on time. So we adopted this approach. We first manually label around 200 examples. After that, which we call DL, then we train a classifier based on Afro-HMR, which I'm going to explain later, a procedure language model. We train a classifier on these 200 examples. Sometimes they are predefined as categorization by these news articles, so we also use them for training wherever they are available. Then we did automatic labeling of the next 3,000 sentences or 3,000 articles. And after that, we combine it with the manual label, and then we did what is called verification. So we send it back to the same annotation tool, and we ask our annotators to verify what is the quality. And our final data set is this DV. And then the verification is done on this platform, which is an internal annotation tool from UCL. And as you can see, you can go through this, basically try to label articles based on the news headline. And if you're not able to give the right answer because of that, you can show more context so that it gives you the rest of the article and you can label appropriately. So the automatic labeling really helps to speed up the annotation because you can just now verify what has been labeled. And then we do some quality check. And if you see, Basically, we measure what is the inter-agreement score between the annotators. And usually in the literature, if you have an Flex Kappa score of greater than 0.4, I think this is great. And for all the languages, we have more than 0.55. So which shows that we had very good quality annotation. But you can only compute this for languages where you have minimum of 2 annotators. So for languages that have 1, we skip the evaluation. Our final data set is this, which comprises, I think, over 16 languages. And most of the languages cover 4 topics. And every language covers at least health, politics, and sports. This is the prevalent topic across all languages. And some other languages will have other categories like technology or business. Some will have maybe religion instead as an additional category. But for some languages, we're only able to put 3. And it was a bit difficult. So for Lingala, we had to try to resolve the conflict between the annotators to try to find more articles for these languages. Because our idea is to have minimum of 72 articles per category in each language. And when that is difficult, we decided to resolve the conflict for Lingala. For Chishona, it was a bit difficult. So we decided to collect sport news from another news website that has a lot of sport news, and we added it to our data set. And again, we did some manual verification to ensure that all the articles we crawled are from the sport news. So the data size of our data set is like from around 870 to 4729 articles. So if there's no question, I would like to move on to the experiment. So for the baseline experiment, let's start with the baseline models. For the baseline models, we make use of classical machine learning methods like naive Bayes, XGBoost, a simple multilayer perceptron. And all these are based on scikit-learn, which is a very handy tool that you can use, and it's very simple to implement. Then we also fine-tune pre-trained language models like XLMR and REMBET. So these pre-trained models, surprisingly, actually, these models support a lot of our languages, like 8 to 10 of the African languages, but some are missing. So it doesn't support like between 6 to 8 languages. And I think there's a mistake here. It should not be fine-tuned on NER, it should be fine-tuned on the news topic classification task. And for us to address that problem, for example, if a pre-trained language model doesn't support the language that you speak, how can you adapt this pre-trained language model to that language? And we make use of our method here, which is called Adaptive Pre-trained Language Models to African Languages. And the title of the model is AfroXLMR, which also got Best Paper Award at Colin. So yesterday, I saw this beautiful pre-trained language model evolution. So this is what we have since 2018. And there's a lot of models. And the question is, which model would you use to fine-tune your task? Typically, there are 3 branches of model. We have the encoder-only model, which is what we're going to focus on today. We have the encoder-decoder, which is typically used for generation task. And we have decoder-only, which is also mostly used for generation task. But today we'll just focus on the encoder-only model. But if you're interested, you can check out this survey that tries to tell you a lot about different language models from 2018. So back to my point, what is the challenge of adapting pre-trained language model to new languages that are unseen during pre-training? The first challenge is what is called this limited language coverage, because pre-trained language models do not cover all the languages. So for a language that is covered, they typically have high accuracy. For languages that are not covered, they have lower performance. And this is due to what is called cost of multilinguality. If you try to cover as many languages as possible, you're going to have this cost of multilinguality because for you to cover more languages, you need to scale the capacity of the model. And even if you intend to scale the capacity of the model appropriately, you are still faced with non-availability of enough corpora to train the model. So, and the second problem is hardware restriction. So even if you have all the data to train this model, it's often very difficult to train this model because these spatial language models are getting bigger and bigger. Fine-tuning them is also difficult nowadays. To address this, what you can do is language adaptation. So you can pick an existing pre-trained language model, fine-tune it on a new monolingual data set of your language, and then you can fine-tune it on your task, whether NER or new subject classification. But this has limitations. Number one, it's difficult to adapt to non-supported script. If the script is not supported and you do all the adaptation, the performance is not as good as a language model where the script is supported. Number two, this labs create a copy. So if you want to train, do this adaptation for 20 languages or 60 languages in our corpus, you have to do this adaptation 16 times, and you create a copy of the pre-trained language model 16 times, which is parameter inefficient. The last one is that once you have adapted it for one language, it limits the cross-lingual transferability to other languages. So to address this, there are two ways. Number one, you could try to pre-train your own multilingual model from scratch that cover more languages. This is what was done by Ogweji, I think, in 2021, but this is very resource intensive. The second approach would be to use a more parameter efficient approach like adapters. And the idea is that you can add, instead of, this is an example of a transform architecture. And the idea is that you can add a small component to every layer. And during fine-tuning, you only fine-tune this small component, this pink component that you have added at every layer. That's the only component you fine-tune. All other ones stays the same. And this is more parameter efficient because you only need to store those new parameters. But the challenge of this is that you still need to do the adaptation for every single language. What we have proposed in our Cohere paper is to do the adaptation to several African languages at the same time. So you pick an encoder, initialize the way that you do language adaptation to several languages at the same time. So this was inspired by what was done by MBAT. So you have MBAT that already covers 25 languages, and then it was extended to 50 languages by training on the 25 languages data that already exist, plus additional 25 languages for the new languages you want to adapt to. And then you now have MBAT 50. But in our case, our interest is not to extend, is to specialize this language model to African languages. And for us to do this, we have to carefully choose what is the pre-trained language model to use. We decided to go for XMR based because it covers all the major scripts used in Africa, and we cover the 17 most resourced African languages. And we also added English, French, and Arabic. And then we have like 20 African languages. And we did the pre-training using the MC4 corpus and news corpus. And with this, we are able to expand the coverage of multilingual pre-trained language model to several regions of Africa, which is quite nice. And this language model has been very effective. And I would say that it's one of the best now to fine-tune on African languages. So let's go through the baseline results to see how this language model performs. So the first one is that we can compare this naive base, which is what you can, a very traditional way of doing things. And if we compare it to XMR large, which is the big XMR model, you will see there's a significant improvement of pre-trained language model over naive base. So which shows that, I think except for Corsa, which is quite interesting, that naive base sometimes still do better for at least some languages. Then if you compare this to more Africa-centric language models, like the solid green bar, AfriBeta large, AfroXMR base, and AfroXMR large. What you can see is that the two versions of our model that we proposed, that I just showed you, had like a more impressive performance across all the languages. Even looking at the average, there's a significant improvement in performance if you use our newly adapted model. And on the news topic classification is the best, AfroXMR large. So which shows that our pre-training, creating more Africa-centric language models that are saying more African languages is better than using a pre-trained language model that are saying less of African languages. Okay. The second thing is that what should we use for what do you call it, for training the news topic classification? For human, if you just look at the headline, it's enough for you to detect what is the category of this news article. But is it the same for news topic classification models? So if you take the traditional machine learning models like multilingual, perceptual, naive Bayes, and XGBoost, you will find out that if you use only the headline, the performance is very low. And if you use headline plus the text of the article, you can get a huge improvement in performance, huge one. So that shows that these traditional machine learning methods require more context of the article to be able to give the right prediction. But the interesting thing is that with the pre-trained language models, like AfroXMR large and Bayes and large, you can see that even with only the headline, they gave very impressive results, even better than the traditional machine learning. So that means even if you have very small information about the article, they're able to predict accurately the headline, the category of this news article. Yeah, this is the last point, if there are no questions. The last point is zero shot and few shot adaptation. And how can we do news topic classification if we have no data at all, and if we have just few examples? Okay. In the zero shot setting, the idea is that there is no labeled examples. So one thing you can do, you can leverage predictions from large language model like ChatGPT, or you could also leverage data set from a more resource language, and you can do what is called cross-lingual transfer. If you don't have the data in Yoruba and you have in Hausa, how can you leverage the data in Hausa to improve the news topic classification in Yoruba? The second approach would be few shot approaches where you have few examples. For example, you can have 5 examples per category. And this is very easy to create. 5 examples for business news, 5 examples for sport news, and then you can easily classify your data set. You can easily run predictions for your data set. But for this method to be highly effective, there are other methods that have been built around it. For example, like pattern exploiting training, PETs, sentence transformer fine-tuning, set fits, and Cohere multilingual embedding API. So, for example, we are faced with this problem. First, I want you to understand that language models have been trained to predict the next word given the context. That is how they were being trained. They just generate the next word. And the question is that, can we use this to solve the discriminative task like text classification? And the answer is yes. You have an example here. You have like 5 examples for business news, 5 examples for entertainment news, 5 examples for health news. How can you do the classification using ChatGPT? You can prompt it. For example, this is an example of a prompt. This is the prompt text. Is this a piece of news regarding business, entertainment, health, politics, religion, sport, or technology? That is the prompt text. This is the headline, and this is the text. So you can take the headline from here and pick the text from here, and then do the classification. For example, we have an example for Tinubu deny, say in one context, 23 presidency. So that is the headline, and this is the text. And if you combine that and you ask ChatGPT, it's going to tell you, yes, this piece of news is regarding politics. Very simple approach. It's something you can try now and it works. So this is very important because this is the format that you can now, you kind of construct your discriminative task to be like an input and output task. So you have an input and the language model gives you a completion. And the completion here is, yes, this is a piece of news regarding politics. Okay, but the question is that how can you convert this completion to a category? Okay, and for you to do this, we will need what is called a verbalizer. The completion of the language model can be a single word. It can tell you just sports news. It can say this piece of news is regarding sports. Sometimes it can give you even more elaborate explanation. And sometimes it says, I don't understand this language. How would you pick the right category? And the idea is this: you need a verbalizer that says, for example, if you have anything that relates to business, make sure you categorize it. You can write a rule, a simple rule, categorize it as business. So if you have in the reply or the completion, you have something like finance, economy, economics, business, you can categorize it as business news. For example, if you have anything that has to do with music in the reply, instead of saying this text is about entertainment, it says this text is about music. You can convert both of them to entertainment. And you need a verbalizer, which is a dictionary that says if you see this kind of words in the completion, convert it to this category. Another approach to do few-shot classification, zero-shot classification is MADX. This is very effective for zero-shot classification. It is modular, so we have a modular, composable, and parameter-efficient adapter. The idea is simple. You need to first train language adapter. In the adaptation section, I talk about you can do adaptation to new languages by training adapters. So you can train an adapter for English, which is a small component in every layer for English. You can train an adapter for Yoruba, a small component in every layer for Yoruba. Then at the second step, you can now try to combine the language adapter and the task adapter together to now train a task-specific model. In this case, it's NER. And after that, you can now replace the English language adapter with the other language, which is Yoruba language adapter. You compose them together, and then you can do zero-shot transfer. And another thing we have tried in our paper is that instead of using XLMR Ultra, you can also use Afro XLMR to give you some slight boost in performance, especially in the target direction. And we find out that because they have the same size, it actually works very well. Okay, the third approach will be pattern exploiting training, which is another approach. And the idea is very simple. Okay, you need to first design a pattern. These are examples of pattern. Headline text. This is an example of a pattern. Just have A, B. You have a pattern like this. And after this pattern, then you now need to train a language model for each pattern based on few examples. So let's assume you only have like 5 examples per category, and then you can train like 5 different models based on the different patterns. So you have a model for pattern 1, model for pattern 2, model for pattern 3, model for pattern 4. And after that, you now run predictions on unlabeled text that you have based on this pattern. And you can now create this soft labeled data sets, T1, T2, T3, T4, based on the different patterns. And after that, you now combine them together with the initial one, so and repeat the process. So let's assume you have 5 examples at this stage. You can now do prediction on another 5 examples from your unlabeled data set, and then you combine them. You now have like 10 examples, 5 fully labeled, another 5 that you have some soft label. Combine it together, you have 10 labels, 10 examples per category, and you repeat the process. And if you repeat the process severally, you have what is called IPET. And at the end of the day, you can now use this soft label to label all the unlabeled text. You now train a classifier on everything that you have, put the label and the unlabeled together, and then you have this classifier C. Yeah, it's a bit complicated, but I'm happy to answer questions if you have at the end. So the last approach would be sentence transformer fine-tuning. And I think this is very similar to the approach that Cohere is using, which I'm going to show you in a minute. And the idea is that you have few examples. And the idea is that like what PET is doing, is trying to create a bit more examples at every iteration. So what SetFit is doing is that 5 examples or K examples you have is usually not enough. We need to create more. And they use what is called constructive learning. And the idea is that if you have like 5 examples per category, you can do constructive learning and pick, like, for example, you can combine, you can pick maybe 2 examples from the same class and as a positive example. And then you can pick 2 examples from different classes as a negative example. And you do what is called constructive learning. And after that, the fine-tuned sentence transformer, you can now use to extract rich sentence representation for each labeled example. I think yesterday you have been introduced to sentence representation learning. And after that, you can now fine-tune this rich representation that you have extracted using something like logistic regression. And this is how we have SetFit. And it's also quite effective. The last approach will be Cohere multilingual API. So this will be a bit difficult to explain, so I've created a video, if you can see. So you can go to the playground of Cohere, and then you click the classifier component. So you can upload a CSV that has maybe the example and also their label. And if you upload a CSV here, you have 6 examples, and you have 2 examples per category. And then you have new examples. So we call this like 2-shot classification. And then you can run your prediction on like the remaining examples you have in your data set. Here you have to select the right model. Here we have to select the multilingual model, and then you have the right prediction. This is one example of how to use the Cohere multilingual embedding API. And we also use this in our recent work. Okay. For the 0-shot classification, we compare PET, SetFit, and ChatGPT. And what you can see is that ChatGPT was the winner in this case. For Amharic, it doesn't fully support it. So what we need to do was to first translate the Amharic text to, we translated the Amharic text to English, and then we run prediction. But because the translation model for Amharic to English was very good, we had very good results. But for Tigrinya, that has the same script, the translation model is not very good. So we have lower performance for ChatGPT. But in general, ChatGPT was better than PET, SetFit for the 0-shot classification. For the MADEX, if you compare this to MADEX, MADEX uses like data from another language. Here, we excluded the evaluation for Hausa. Sorry, we leverage Hausa and Swahili as source languages. We assume Hausa and Swahili have a lot of examples, and all the remaining languages do not have. And the reason is because Hausa and Swahili cover all the language, all the labels we're interested in, like business, technology, sports, religion, and all that. And you see that MADEX is very powerful, and actually gives you very impressive results, better than ChatGPT if you have labeled examples in another language. And for few shot approach, if you have few examples, we show that the more examples you have, the better the performance of this different approach. So if you fine-tune just even our best model, AfroXLMR, on 5 examples per category, you see that the performance is very low, is less than 55. But the interesting thing is that if you use, also for lab C is not very high, but if you use approaches like set fit, you find out that you can have a very big jump in performance, a very big jump in performance. If you set fit, and if you use the Cohere API, you also get some improvements, which is quite similar, for example, with the set fit. But PET approach actually gives you the best results in this case. Okay. And I guess that's the end of my talk. Here we address 2 major challenges in building language technologies for the resource languages. One is lack of data sets and limited coverage of African languages in multilingual representation models. And we introduce participatory research as an effective way to create new benchmark data set for African languages. And today I present MasakhaNEWS. And also we provide different baseline results and several alternatives to full fine-tuning methods that are better suited for zero-shot and few-shot setting. Yeah, thank you.
Thank you very much, David. This was a very interesting and well-detailed presentation and interesting work as well. So yeah, we have a question in the chat. I think you can take it. I believe the question is for you. It's from Just Joba Alabi.
Okay.
Thanks for the great talk. There are still over 1,000 African languages not covered by these datasets and pre-trained models. What is the way forward?
Yeah, so that's a great question. The way forward is also a research question. How do we address this non-representation? One thing is that I still believe we cannot get data for all these languages. But what we can do is that how can we benefit from related languages, for example? So there's some languages that are very close to each other. So if you have one of the languages has a lot of data, you can leverage what is called transferability again to do very well. Another thing is that you could use this approach like MADEX. The good thing with approaches like parameter efficient approaches like MADEX is that they do not require a lot of unlabeled text to actually create a language component or language adapter for that particular language. If you're able to get like 1 MB of data for that new language, which is hard, but there are some corpus that you can easily get 1 MB. For example, if there's a Bible in that Bible corpus in that language, for example, you might already have 1 MB of data. And if I'm not mistaken, we have up to 1,000 languages in Africa that have like the Bible. Maybe it's not Bible, it can be Quran in that language, it can be any other text in that language. So even if it's just 1 MB of data, you might be able to do good adaptation for that language.
There is another question from Lukman Aliu. It says, what is the most documented African language? Can it be transferred to the least covered ones?
Yeah, that's a great question. Yes, it can be transferred. For example, I think Swahili has probably the most labeled data set, if I'm not mistaken. So you can use Swahili to adapt, but it's not all languages that Swahili adapt very well to. Yeah, so you maybe Hausa will be better in some other languages, and Yoruba maybe for some other languages. So you also have to find what is the best language to transfer from.
Awesome, thanks for that. Ayodele has a question. She says, thanks, David, for the presentation. Now that we know from your research that classical ML's performance are not as good as pre-trained models, e.g. AfroXML, would you still advise we explore these classical ML approaches?
Yeah, that's a great question. And the answer is yes. In some cases, if you look at some of the results, you see that there's the performance is not as good as this special language model, but the thing is that they require less number of parameters. So here, even on your CPU, you can easily create the scikit-learn model, and you have like 85% on average. So if you do not have any GPU resources, you do not have any budget to spend on hosting this model, this like classical ML methods can still be useful. But I think it will be ideal that you provide them with more context. That's why we have this experiment. Don't just do classification with headline, provide them with the entire article, then they can have a more reasonable result. The second approach is that you can use smaller versions of this model. We have AfroXML base, but we also have a smaller one, which is called AfroXML small, which might also give you something better than these ML methods, and without using a lot of compute resources. I skipped that in my presentation, but you can also find it in our calling paper. Yes, do we plan to create this? That's a great question. If someone is interested in leading that, good. Personally, I'm not sure if I have this plan, but if other people in the community are interested, yes, they can go ahead. We'll provide the support they need. And this is actually true because I was doing some prompting yesterday, and I found out that there was an article that talks about Elon Musk doing business on Twitter, and actually ChatGPT is saying this is both business news and technology news, which is correct. But if we run the classification, our method is just going to say that this is incorrect. So I think it's important.
Okay. Thank you once again, David. And thank you to everyone who has sent in questions. I believe your questions have provided more context and more insights to the topic that has been discussed. And to be very honest, it's an interesting and ongoing conversation that needs to be had, and it's always going to yield different insights for as long as the conversation goes. So thank you to everyone who has participated today.